Assalamu alaikum students, myself is Bushra Khan and I am from Meem Grammar School and College. I am going to teach you biology and the topic of our lecture is factors affecting rate of enzyme action. It is present on 109 and ends on 111 page of your textbook. Now come to learning outlines. What we discussed today. First of all, we discuss factors affecting rate of enzyme action. The subtopics comes introduction, then first factor is temperature, which includes optimum temperature and denaturation of enzymes. The second factor is substrate concentration, which includes saturation of active sites, pH and optimum pH. Factors affecting rate of enzyme action. First of all, introduction. Enzymes are very sensitive to the environment in which they work. So, any factor that can change the chemistry and shape of the enzyme molecule can affect its activity. Some of the factors that affect the rate of enzyme action are being discussed here. First factor is temperature. Increase in temperature speeds up the rate of enzyme catalyzed reactions. Those reactions in which enzymes are present are called enzyme catalyzed reaction. Whenever temperature of those reaction increases, the rate of enzyme catalyzed reaction also increases. Then comes what is actually optimum temperature. In simple words, we can say that enzyme works at its maximum rate at specific temperature. Specific or certain set temperature is called optimum temperature. Then comes denaturation of enzyme. What is denaturation? It is actually the destruction of enzyme molecule. How it happens? When enzyme is raised above optimum temperature, when our set temperature is raised or increased, heat energy increases the vibration of atoms of molecule and globular structure of enzyme is lost. As you see in graph, when we are increasing on one side x-axis, we are taking rate of enzyme catalyzed reaction, and on y-axis we are taking rate of enzyme catalyzed reaction, and on x-axis we are taking temperature. In the start, as we increase the temperature, rate of reaction increases. But after optimum temperature, when we are increasing temperature, rate of reaction does not increase, it decreases. So, decrease in enzyme action, blocked enzyme activity, and enzyme denaturation occurs after optimum temperature. Then comes substrate concentration. If there are some enzyme molecule with vacant active sites, vacant means empty active sites, An increase in substrate concentration will increase rate of reaction. Same in substrate concentration. Whenever enzyme molecules have vacant active sites, it increases rate of reaction. And what is active sites? Saturation of active sites. If enzyme concentration is constant, means they are fixed in number, amount of substrate is increased and a point is reached where substrate does not increase the rate of reaction, means the fixed number of enzymes are used and they are not vacant, and by the addition of substrate we cannot see increase in rate of reaction. As you see in graph, on x-axis we are taking substrate concentration and on y-axis we are taking rate of enzyme catalyzed reaction. In the start, when we are adding substrate in reactions, rate increases, and when all active sites occupied, saturation of active sites done, rate of reaction remains constant, means rate of reaction does not increases. Then comes third factor, pH or optimum pH. Enzyme work at their maximum rate at a narrow range of pH called optimum pH. A slight change in this pH causes retardation or destruction in enzyme activity or blocks it completely. Means if you change the pH of any enzyme, it works stop, its activity stop, and it blocks completely. Every enzyme has its specific pH value. For example, I have given you examples in table. Name of enzyme is pepsin. Where it is present? It is present or working in stomach, and its pH is acidic. Then comes trypsin. It is present in small intestine and its pH is alkaline or basic. These pages are taken from your book. Factors affecting rate of enzyme action, temperature, then we have discussed the graph, then substrate concentration, then its graph, and then pH and effect of pH on enzyme activity. After optimum pH, enzyme activity slows down. These are the related links. Thank you.